So I think we did a lot of questions from Newton's laws of motion, right?
Yes.
Yes.
Today we can go to the friction, which is part of laws of motion itself, but we'll keep as a separate topic. We call it friction. Okay. By the way, who is Shivan? I think this name I haven't heard. Okay. Shall we start now?
Yes.
So in friction, we have two types of friction: is static. Static. We have friction. Now static Fs, dynamic Fk. And there is no formula for static. We have formula for dynamic, which is nu k into n. But if static can reach the limiting value, then we do have a formula. So always remember that static friction cannot have any formula. You cannot write Fs equals to something, which is wrong. But in the limiting case, which is called the limiting friction, the upper limit that you can develop will have a formula. So it's like the bound. This is like boundary value. Okay, this is called the boundary value. Which means two surface can develop this much static friction up to this value for the given normal reaction. So definitely as you grow the n, the Fs max will also grow. And as you decrease the n, the Fs max will also decrease. And here in case of kinetic friction or dynamic friction, because it is about the relative motion is happening, the two surfaces are rubbing each other. In that case, whatever normal you have developed into the mu k will give you the kinetic friction. And then there is a exponential graph which you should remember. If you plot the friction force between two surfaces and applied force, kind of, let's draw a simple block upon a rough surface, passing over a pulley, and then pulley is attached to a pan. And in this pan, you're pouring some sand particle. So as you pour the sand particle, the gravity will increase, and this will increase the tension. The tension will reach here. The T will try to pull the block, but the block is stopped by the friction. So this friction is static in the beginning. Now, if you add more sand particles, the weight will grow, T will grow, this will grow. So again, it will balance. So this will also grow actually. And it will keep on happening because it can grow up to the limiting value, which is predetermined. So we know that how much you can grow up to. So this is well defined. So for a given normal, the value of limiting friction is well defined, but friction will try to, act as per the requirement. It will not, act to the limiting value in the very beginning. So it acts as per the requirement, how much you need, it will grow. And then if you plot a graph, it will get a very nice straight line graph. So let's say tension is a graph, and in this case, T and Fs are equal. So this is exactly 45 degrees because they are parallel forces. And then the moment you reach the limiting value, if you increase the applied beyond this value, the F will not be able to increase its value beyond this value. And there will be, the motion will ensue, the motion will start, and therefore the nature of friction will change from static to kinetic, and there is a kink actually. It means there is a sudden decrease in value. And now the next friction is called the kinetic friction, which is constant in nature and depends on the property of surfaces. So once you have the similar you can say irregularity over the area of surface, you have the similar friction forces. And now there is a huge difference theoretically, which I have discussed if you have seen my videos. The cause of these two frictions are not same. Okay. So kinetic friction is due to, what? This is due to the, it's called soft collision. So if you try to move it, you have to actually overcome the mountain actually. And so while moving, you hit the mountain peak. And in the due process, you also tear apart the peaks also, many cases. So that's why due to the relative motion, you actually face the opposition because of the continuous collision which you face. And these are of like a nanometer dimension sometimes, or sometimes more also. Some micrometer, sometimes few hundred micrometer. It can go up to millimeter also. So if you go and buy the sandpaper, it comes with the coarseness, like how coarse the sandpaper is, and you can get up to millimeter coarse sandpaper, which can really, used to remove a bigger surface area. So depth, it creates bigger depth. So depending on the kind of polishing, you use different grade sandpaper. It comes with some grading actually, that very fine grade, coarse grade, and so on. So the reason of kinetic friction is simple. It's because of the collision factor, but static is not due to collision. So static is due to the cold welding, right? So you get a structure. It's like, they are like glued together. So when you try to move, the glue will try to stop it. Okay, so there is some, you can say, like a very slight movement, but the two peaks will still glue to each other. And what happens to set the body into motion, you need to first break the glues. So this is called the interlocking points, and unless you will not break the interlocking points, it will never be set into motion. So you could first break it, and it will have the ability to hold up to certain value. That's called the limiting friction. So you can hold up to limiting value. Beyond that, the interlocking will break, and once you break this interlocking, then what happens? Then the nature of friction will changes. It will be now due to the irregularity of the surfaces. Now you face kind of bumpy ride. So the friction due to the bumpy ride we call kinetic friction, but friction due to the, you can say, cold welding or interlocking is called static. So that's a two differentiation. That is also the reason why highly polished surfaces are not good. They don't reduce the friction; they rather increase the friction. So if you have highly polished surface, it won't be easy to move one over the other. You know why? Because of infinite interlocking points. So if you make something really smooth, you also make a infinite interlocking points, and with the increase of interlocking points, it is very difficult to move. And that's it. That is why, like, if you have two glass slab, if you take a large glass slab, if you try to move over each other, it's very difficult. If you go to any glass cutting showroom or factory, you will see that they don't push the glass over each other. They lift the glass and then they pull. I hope you have seen this somewhere. So if you try to move one glass surface over the other glass surface, expecting that there will be no friction, you will get the reverse. And there will be tremendous friction. So highly smooth surfaces are not good. Okay, so they create a tremendous friction. So that's the theory. Okay. So things to remember, they have different cause. They are not due to the same cause. Kinetic is due to the this bumpy ride, or you can say collision between the peaks and valleys. So the peaks and valley collide, and that creates a kinetic friction. That's why there is a loss of energy in kinetic friction, but there is no loss of energy in kinetic friction, right? So of course, energy can be given, because if it will move and if the bottom is also moving, let's say if I have a block of mass M1, it's kept on a frictionless surface, but it is having another block of mass M2 kept over the surface which is rough. And if I apply the F, then what will happen? The glue between M2 and M1 will try to pull each other, right? And this invisible glue, which we call friction, static friction to be more precise, will move M1 as well. But you need to remember that in the due process, the force will impart energy to block, and the glue will impart energy to the M1, right? So M1 will get energy from by virtue of work done by the which force? How M1 will get the energy if they are moving together? Then tell me. My force is on M2, right? On the upper block. So the work done by my force, the applied force, is on M2. So I am imparting energy to M2. But the question is, who is imparting energy to M1? Tell me.
Friction.
So it is the friction which is imparting the energy to the M1. And because, as I said in the last lecture, static friction acts as constraint force, which means whatever energy it will take away from M2, the same energy it will give back to M1, right? Because the role of constraint force is to transfer energy without diminishing, without consumption, without wasting or converting into the form. So that is the role of constraint force in transferring the energy. Okay, so F gives energy to M2, but friction takes away energy from M2, but the same friction gives back energy to M1, and it will do exactly the same value because there is no relative motion. But in case of kinetic friction, what will happen? F will give to M2, and the friction will be kinetic. So kinetic will take away energy from M2, but what it will take, will it give the same? Tell me. kinetic friction will take energy from M2. Is it going to give the entire energy to M1? Yes or no?
So some energy will be lost as heat.
Not necessary.
Yeah. So the question is, why? Like how you can explain this scenario? Like why it will not give the same energy? So it is due to the relative motion. What will happen is that if M2 will travel x distance, and because there is a relative motion, will M1 travel x or less than x or more than x? What do you think? If M2 travels x away, what M1 will travel?
Less than X. Less than X.
It will travel less than x actually. So when it comes to taking energy, so if friction has taken energy up to this distance, so friction has taken energy fk x2, but while when it comes to giving, it has only given. So it has taken more and given less. So net is not the same, right? But when it is static friction, we know that the displacement will be similar. And therefore the net is zero. And here clearly you can see that you take more, but you give less. So rest you waste. Okay. You waste, you dissipate. So you create heat energy. Understood? So what is the heat energy basically? The difference, right? So the numerical difference is the heat energy. Like this much you had taken. Okay. And this one you have given. And the rest will become heat. If you add heat, it will become conserved one. So because without heat, it is not conserved. And we say this as non-conservative force. But if you take heat into picture, then everything is conserved in nature, because what we call loss in form of heat dissipation is also part of this universe only. And if somehow you can harness, which we do actually in some cases like heat engine. Of course, we can't harness 100%. We can harness up to a certain extent. So if we create some isolated system in which there is no molecule, if we have a perfect vacuum, then the energy will heat up the body molecule itself. Anyway, so you need to remember that in case of, okay, this is also part of work done chapter, that static friction when behave as internal force will always dissipate energy. But if kinetic, sorry, if what I said wrongly, I said static. When it is kinetic friction, it will dissipate. When it is static, then there is no loss of energy. And that is why, if someone will ask you, can we conserve energy in the presence of friction? Can we? The answer is yes, we can conserve. If friction is static in nature, it will never lead to heat dissipation, and therefore energy can be conserved. And that is why when you solve question of a rolling motion or SHM of a rolling object, we know that a rolling friction is static in nature, and therefore there is no heat dissipation. Therefore, even though we have friction acting, we do conserve energy while acting the equation, right? I hope you remember
Yes,
this.
sir.
So energy conservation is all depending on this simple idea of friction. Now, even though you know that fact that, okay, static having no formula, but kinetic is having formula. I have seen student making mistake. They write Fs equals to mu Sn. So one should not write Fs having no formula. How to determine Fs? So Fs is only determined using the free body diagram and the situation, the context. You have to solve the laws of motion to get Fs. So you always assume Fs as Fs, that's it. And you will solve the laws of motion, and from there you will get the answer. You cannot write formula for Fs. Okay. But whereas Fs max is having well-defined formula, which is Now the idea is the Fs max is having formula, which is mu into n. Every question in which you come across the word like a minimum, maximum, like what is the minimum force to move the block, what is the maximum force which cannot move the block. So when they use the word minimum or maximum, they reach the critical situation. And to solve any question of critical value, you can always replace Fs by Fs max, and then you can solve for it. So that is the whole idea of static friction. The third concept about friction is angle of friction. Just so we have a habit of looking at normal reaction and friction as two separate entities. This is our habit. We always believe that these are two forces. Are these two forces? Are these two independent forces? Yes or no?
We can call them part of a single reaction force.
Yeah. So these are basically component of only one force called the surface contact force. So this is the I have discussed in the very first class that surface contact force will have two categories. It is we divide into N and F. So these are not two forces. One surface can apply only one force, no? If there is one surface, then there should be only one force called the surface contact. So this is called surface contact force. That's it. So when you draw a diagram, okay, it will start with easy. And right now, do you see any tendency of this block to move if the surface is horizontal or flat?
No.
No. If there is no, if there is no tendency to move, the only it can do is it can only press the surface back downward because the earth is pulling, right? So gravity to oppose the gravity, it will exert force. And therefore the normal will be the reaction force. So the total surface contact force is equals to normal. But imagine someone starts applying force like this. And let's say the force is not big enough. Now, when you try to pull like this, basically you try to understand the gravity is pulling this way and you are pulling this way. So actually the net force as perceived by the block is this way. No? So block block understand on the net effect. See, as a human, what you feel is the net effect, or even the body will feel the net effect. So for body, this is the net effect. So this is something like a resultant. So to oppose this, the surface will get force like this, which we call the surface contact force. So Earth will not apply force upward or left. No, it will apply force only one direction. This is the only force applied by the Earth. which you can resolve as per your convenience of writing. So there is nothing like a normal and friction. You have always only one force, which is the R force. And this R force will have two components, and I'll tell you this R, we call this as lambda. So this R force will have two component, or the vertical component, which you can say R cos lambda, and horizontal as R sin lambda. And this is in history, this later on we just named it. So R cos lambda, which is normal to the surface, we renamed as normal reaction, and R sin lambda we renamed as friction. So this is the history. Okay, simple. And this angle is called the cone of friction. So when you are acted upon by multiple forces, then if it is the earth, if it is the surface which it has to balance it, it will balance the net force, not the individual force, right? So if you know what is the direction of net force, you know the direction of balancing force as well. And if I remove if I remove this force, what will happen? The mg is the only force. So to balance this force, the earth will apply force upward, right? So this is what you need to remember. All right. So we have something called cone of friction, which I will write once again. So in many situations, you will find this method of writing very interesting and easy. Sometimes it solves the question very effectively, very fast. So if I believe that this block is acted upon by some force, and therefore there is some tangential component as well, there is this component which you call as normal and friction. Okay, let's go like this. The earth is actually applying force, not this way, it is applying this way, right?
Yeah.
This is the called the surface contact force. So when someone will ask you find the force due to earth, many students, they find the normal, they become very happy. I got the right answer. So force by the earth on the block is how much? It is n square plus f square. Now, in the worst case scenario, if there is no tendency, if there is no parallel force to the surface, then f becomes 0, right? So what is the minimum value of r? N. And what is the maximum value of r?
N square plus f limiting.
So the maximum value is mu square, which mu can be mu s or mu k, depending on whether it's moving or not. So the earth reaction force can vary between n to n under root 1 plus mu square, right? In this case, I think we can also write as mg2. Correct. So earth force can vary significantly depending, but we are particularly looking for one particular case situation called the limiting case. Because when you solve question, we solve question mostly for the critical values, the limiting case values. And try to understand this part. This will change your life forever. So if I say that the force is limiting, something magical happens. So let's say so if it is limiting value, then this will become mu s n, right? So let's say friction has gone to the maximum. So how much will be the value of fs max? Mu s into n, correct? And because of this reason, this angle becomes well defined. So what is tan lambda? Tan lambda is how much?
Yes.
Yes.
It doesn't matter what is the mass of the object, right? Isn't it
Yeah.
interesting? I mean,
Yes.
however heavy the object is, whether it is an elephant or an ant, in both cases, the resultant force acting on the body will have finite direction. That's very interesting and amazing. That in a limiting case, the force will act in this particular direction only. There is no choice left. Yeah. There is no choice. Sorry. So there is no choice left. It will be exactly in this direction. And the direction is well known to you. I know tan lambda is how much? You can attest mu s. It is. So once we have the well-defined mu s value, we know what is the angle, right? And in case of kinetic friction, it is again defined, right?
Yes.
So in case of kinetic friction, it is again well defined. Okay, so this is what you need to remember. The last concept from friction is called the repose concept, angle of repose. So what is the angle of repose? So if we have a plane and it's a rough plane, there is a block. And as you start tilting the plane slowly, at one particular angle, what will happen? The block will start coming downward, right?
Yes.
So the angle at which the motion is impending, about to happen, it has not happened, about to happen, is called the repose angle. So when it is about to happen, we call it has reached the angle of a repose. And what is really interesting that when it is repose angle, then the friction must reach the limiting value, right? Mu s n, correct?
Yeah.
And and mg will act like this. And it is about to reach, which means the friction is limiting value, but it is not moving, so it is still at rest. So what should be the direction of surface contact force at this instant? Who will tell me?
Vertically upwards.
So the surface contact force throughout this rotation will be always this way,
Yes.
because you have to balance mg only. No? So surface will apply force to balance the net force, which is mg only. The n and mu s n are the force due to, I mean, it's just one force. So r will have component actually. So no matter which angle you turn, it is always this way, and that's why it is so interesting. If r is vertical, then we know this angle is also, if this is theta, this is also theta, correct?
Yes.
And we know that this angle is actually tan inverse. The r and n makes what angle? Tan inverse?
Yes.
Yes. So this is also repose angle, right?
Yes.
I mean, we know this fact directly, right? But if you want to solve, how you solve, you know this answer. So you write as. So when you solve for the first time in the past, You should solve like this. Just a moment. Mu mg cos theta, because that's the n value. Mg cos theta, and this is mg sin theta, and because this is the limiting case, so at this angle it is becoming, they will become equal. So mg sin theta is equals to mu mg cos theta, and mg gets cancelled. So what do we get? Tan theta goes to mu s, right? And that's why this is called the repose angle. Now, what I'm trying to explain, of course, you can solve the way you have been solving, but if you can see this way, you will have much better picture of the situation. So the surface contact force, they will ask you the question. Before theta r at any angle less than equals to theta r, the r is always equals to mg, you know.
Yes.
Yes.
Because it will be at rest in every case, no? As long as the angle is less than repose angle, the block is at rest. And if the block is at rest, it means it has to only balance the gravity, right? And
Yes,
to
sir.
balance gravity, R1 must be in which direction? R must be opposite to gravity, isn't it? What I said, the surface apply force against the net force, correct? To keep things in equilibrium. So the surface contact force is always opposite of mg. It is always vertically upward, no matter which angle you have. Okay, it is less than that. And if you slightly increase, what will happen? The mu s n will decrease, no? Because mu k is less than. Remember, theoretically, mu k we assume less than mu s, right?
Yes.
Because of the kink, right? If you remember the kink, this is mu k n, and this is peak is mu s n. Okay, I hope you remember this graph. But anyway, so the moment you grow beyond this value, now the angle will actually be, the R will not be vertical. R will be towards left or towards right or vertical. I mean, this line. What do you think?
Towards the left.
It will left. Now the R will be something like this. And it will tilt by some angle. Basically, this angle you can find, it is tan inverse mu k actually. This is alpha maybe. And the alpha is basically how much? Tan inverse mu k, correct? It won't be mu s. Am I right?
Yes.
And because of this reason, the mg cannot be balanced. Mg, even if you try to balance, it won't balance, and therefore it will slide down the plane. Okay. So whole idea is, this is a different perspective of looking at the problem. I'll show you some numerical. Okay. So okay, so far so good. So what is the condition for slipping? Condition for slipping is the angle of the incline must be more than. And do you realize these angles are nothing to do with the mass? From the cone of friction, this is called the angle of friction. Also called cone of friction because of the reason that this R can have any direction like this over the cone. That's why it's called the cone of friction. Because this vector can change, right?
Yeah.
So as I change, this will change, right? So that's why we have the R will trace the generatrix of the cone, right?
Yes.
And that's why this angle lambda is called the semi-vertical angle of the cone, and you may say this as angle of friction. But that's very easy. I think this is not difficult to decode. Now there is something really, I mean, peculiarity. You can see that all these questions, I mean, these angles, which is called lambda or repose angle, they are independent of mass. It means the surface will determine the angle, the property of surfaces in contact. That's why the mu s mu k really matters. What really doesn't matter is the mass. So sometimes you may get confused with the mass, but you should be, you know, confident enough to understand that okay, the mass will not matter. I just need to check the mu s. And so how we check actually when we solve problem, what we do actually? So you check two things. You check tan theta, it's tan and the angle of inclination, tan of the angle of inclination, and you check mu s separately, which is because they will give you the mu s. And once you have these two numerical values, because generally if you solve the JEE problem, advanced problem, they mention very nice values. I mean, of course, it's very nice, like 1/2 root 2, as you know, it's very nice. And 0.87 or maybe 0.786, like this. Okay. So they create a nice value. And of course, values like this, you have to sometimes actually convert into decimal to compare. Sometimes it becomes difficult for you. So I will suggest that remember the value of 1/√3, because everyone knows the value of root 3. What is 1/√3? 1/√2? 1/√3 is how much? Anyone knows? No idea. I think 0.5 something, right?
Yes, sir.
Yes,
One-
0.57.
0.57.
Yeah.
Okay, you can do the calculation. I mean, let's not guess. So remember certain values, which, but generally they mention, don't worry much. I know. 577. It's a very famous answer. And 1/√2. This is even more important. Okay. So let's say you're solving question in which you know that cos theta equals to you got 0.7. And you are wondering how to answer the question. But if it is 0.7, you can roughly make it. And then theta will become. So this kind of numerical manipulation is also expected from the student. If are solving question in which you have to find the angle, but your answer is 0.57, you have to be smart enough to understand this is tan 30. So in solving numerical, these numerical values are also equally important, and one should be aware of that. If I need some angle, then I have to look for the nearest value in which this has happened. And that's why I say always remember some typical value, like one should know √3/2 value. How much is this? √3/2? 0.86, right?
0.866. Yes, sir.
8, 6.
I hope you got the idea what you are supposed to remember and practice. So just keep this thing in handy. It's like it should be part of your memory so that you can quickly jump to the angle without much effort. Anyway. Oh. So I'll take one question. Okay, so we'll start with something very simple question. Find the minimum force required to move the block. Find the minimum force required to move the block. Everyone.
Sir,
Yeah, tell me.
sir, mu mg by under root 1 plus mu square.
Correct. So the minimum force required is, so I hope you
Yes.
all got the answer.
Yes.
Yes, yes.
Yes.
So this is a very typical for question I think you all have seen. So how you solve? What you did? Parv, explain.
Sir, I assumed applying force at an angle theta with respect to horizontal.
Mhm.
Uh,
And then balancing the forces.
then F cos theta should be greater than equal to the friction force.
So what will that here?
It should be mu s F.
Correct. And the N is here and mg right like this.
Yes,
So what is N here?
it would be mg minus F sin theta.
Very good. Okay, so now I believe you must have got the right answer. So we'll see a slightly different perspective of what we learned today. So we know that in case of limiting friction, the resultant surface contact force will be always like this, correct?
Yes.
With well-defined direction. I mean, no need to worry about direction. It is going to be fixed, right?
Yes,
So let's call this angle as phi or alpha. We know alpha is mu s, right? And because I'm writing this force, then which force I should not write? The normal and
Friction.
are not required. So what are the other forces acting? Mg. And we are supposed to apply a force, something like this to kind of pull this object, right?
Yes.
And it should be minimum also. I mean, they are saying that can you draw the minimum force? Okay. So slightly trick. So what I'll do is I'll simply extend this force, this line. Okay. So the R, see R, which force is variable? I think R is variable, right? So mg like constant value. Mg is a finite vector. R is not a finite vector. R depends on situation. So what we do is this is R vector. This is mg vector. So because if a block is at rest under the application of three forces, so it's a question of equilibrium. Then what kind of triangle it should form? I mean, polygon should form. Three forces under equilibrium means all three vector will be enclosing a polygon, a triangle.
yes,
So the third vector I can take as maybe like this, maybe like this. I don't know where. But how one should take to make it minimum? You want a minimum value, right?
Perpendicular to the
right
R
angle.
line.
So the only way we can do is by making it perpendicular. And this is my F. Let's and I'm done, right? This is alpha. This is mg. So what is the relation of mg and F? So I know F equals to mg sine alpha, right?
Yes.
And that's the answer. Because we know the triangle alpha mu s 1, this is 1 plus. So what is sine alpha? You can check. Opposite upon I mean, so this is the geometrical solution to the same problem. If you can think this way, it's amazing, isn't it?
Yes.
Elegant way of solving. I'll show you many applications of this, not only this. The entire question of circular motion can be solved by this method. See, both are easy. It's not like difficult. But sometimes it really becomes very effective and faster method. All right. Done. So you might have come across question like this. There is a wedge. Hmm. Imagine if I say this is not, yeah. So in a situation when the wedge is at rest, what do you think? What will happen? It will slide down or it will remain at rest? Block will go down the plane, yes or no?
Yes.
Given this condition. So tan of inclination is more than mu s, which is more than a repose angle, right? It is like, you can think this way. It is like a tug of war. If mu s wins, you stay. If mu s loses, you move. So who is the winner here? The tan theta, right? The bigger is the winner. So because tan theta is more than mu s, you won't stay. All right. So the block will have tendency to, I mean, not tendency to, in fact, go down. I hope this is clear so far.
Yes.
Very good. So my question is, to keep the block at rest with respect to the wedge, what is the minimum force you're going to apply? You know why? Because as you push the wedge, what will change? Can you
Normal.
realize? You will increase the normal actually. By pushing hard or by accepting the wedge, you will increase the normal, isn't it? Someone may think in terms of pseudo force that it will the block will experience a left pseudo force, and therefore it will add a component to the normal reaction, isn't it? That is also a way of thinking.
Yes.
And it will also have a component against the gravitational pull. So in a way, it can stop it. So my question is, what is the minimum force you should apply to keep the block at rest? What is the answer? Solve it. Okay, solve it the way you know. Then I solve. Draw the FBD, then do whatever you want. If you want to solve by pseudo force method or whatever method, you're free to do so. Just go ahead and do it. And because the block is at relative rest, it means both will move together, right?
Yes.
Yes.
Got the answer, Josh?
Just a second.
See, whatever method you know, you first try with that method. I'll show you how to solve in a very different way, which can give the answer in one line. So you want some more time? Okay, 2 more minutes. Then I'll solve.
So check the photo.
Just. So you can take mg outside, right? Common.
Ah, yes, we can do that.
And then you will get mu cos theta minus sin theta. Eh?
Yes.
Something is wrong with the
Upon cos
order.
theta plus mu sin theta.
No, something is wrong with the order. It should be sin theta minus mu cos theta.
I was also thinking that because then, but we don't know the value of mu now.
It is less than 1, let's say.
Okay.
And why
No,
you wrote
wait,
f?
it's correct.
Why you wrote f there? F on the right side. F is acting on the left, no?
So f that is f dash, not f.
Okay.
And f dash is I've written down. See, f into m small m upon m plus m.
So you're writing mg sin theta plus f dash cos
Cos
theta.
theta must be equal to mu mg cos theta minus f dash sin theta. Brackets in bracket.
Something is wrong here itself. Your ABD is you need to recheck actually. The ABD part is not
Okay,
right.
okay, wait, I'll check. I guess there is a sign difference over there.
Okay. Thank you. So first of all, okay, I'm asking the minimum force. It means I'm keeping the tendency of block is still going downward. So when it will have tendency to go down, how the friction will act?
Upwards.
Upwards.
Up.
Yes. So it will try to go to the limiting value. So the resultant of these two forces will be in which direction? Something like this, correct? And we know this angle, right? This angle is on. If I call this as theta, this is theta only, right? From geometry? No, 91 theta. Theta. Okay, is this correct?
Yes, sir,
Okay.
91.
Okay, and the other force is mg, right? Okay, let's go here only. So we're done with all forces, R and mg. I mean, there is, see, we have always two forces, isn't it? This is really easy. So what is the, see, if the block is at rest, then what is the vertical force doing? The vertical force must be
0.
vertical force must be balancing each other, right? So what we can write is, what we can write? Hello. What is the component of R in the vertical direction?
Cos alpha.
R cos alpha.
R cos
Alpha
vertical
is
direction.
minus theta. R sin alpha.
You have to find this angle first, right? Let's call this angle as beta. So beta plus alpha plus 90 minus theta is 90, no? Correct?
Yes.
So
Yes.
beta is how much? Theta minus alpha, right? So R cos beta is balancing mg, isn't it? Hello.
Yes.
So what R is doing then? Then we can say R sin theta is giving the, sorry, R sin beta is giving the, this is R sin beta. This is R cos beta. So R sin beta is giving the block accession same as the wedge, right?
Yes.
And we are done. A by G equals to tan beta. And see, we have done this question a long time back. Without friction, but we have done without friction. The tan theta equals to A by G, right? We used to solve.
Yes.
So A is G tan beta, which is tan A tan B. Tan A tan B. We are done, right? Tan theta is tan theta, but tan alpha is mu s. And therefore the force equals to M plus M into A over. So now you can check, everyone, just you can also check now. So everything you wrote was incorrect. All right, which will look like, I mean, if you want to expand it. Sin theta minus mu s cos theta. And then cos theta plus mu s sin. Do you realize the power of this R? If we ignore this mu s and n, we drastically reduce the effort of solving question, isn't it? Only if you can realize. Okay, I think you guys are not able to digest this method, right?
Sure, it will take some time.
So you can go back to the old method. If this is not getting into okay head, then no point in learning this also.
No, sir, like understanding, but for application, it will take time.
Yeah, application will take time. So you understood what I explained. Do you guys able to understand what I
Yes.
explained?
Yes.
Yes.
Okay,
Yes,
okay,
sir.
okay, fine. So this is a very typical question. We have done this
Basically, like
before.
we are just replacing the N and F with that R, right?
With proper angle. This alpha.
Ah.
Sir,
And the rest is same, no? Laws of motion only. So rest is like I know that the block will accelerate, right? If
Yes.
the wedge will go right, the block will also go right with the same axis. So I can say the net force right equals to M into A. So that will take away, the effort of resolving the mg and all, right? So I'm not
Yes.
writing lot of forces. Okay, this is my answer. Do you realize this? This is my answer. The rest I have written for you for you guys. But in my brain, this answer is always there. So you can also create a kind of, you can solve in 1 line, 1 minute, 20 seconds. So the same question will come: what is the maximum force I can apply?
Sir, am I audible?
Yeah, tell me.
Sir, I don't understand the basic condition that is applied here.
Okay, see, first of all, if you do not push the wedge, the block will slide down from here.
Yes, sir.
You want to keep the block at rest, it means what you have to do? You have to push the wedge right.
Yes, sir.
Okay, leave this question. If you remember the question from laws of motion, which is very typical question again, and that is without friction. And no, there is no friction. What is the force required to keep the block at rest? Here we don't say minimum, we simply say force required, because there is only one value which can do it. How much force will apply to keep the block at rest with respect to wedge? Of course, not in ground. So when you apply force on the wedge, it will have some acceleration A towards right. Now block is at rest in which frame?
In the frame of the
Block
wedge,
is at
sir.
rest in which frame? In the frame wedge. So in the frame of wedge, let's draw the ABD for the block. So
Yes,
what are
sir.
the ABD? MA, MG, normal, correct? This is pseudo force, so not a regular force. Is this clear?
Yes, sir.
And to keep this at rest, what do you say? You say that MA cos theta is same as MG sin theta.
Yes, sir.
You got A equals to G tan theta. You do remember this answer?
Yes, sir.
Now the same question I am changing here. I have brought a friction here. Now,
So
yes.
the actual force that is applied by the surface in this case is normal, but in that case it is
Yeah, normal and friction
the
both.
yes, sir.
So now what is happening? The moment you introduce the mu s, if you push the wedge very hard, the block will skid up the plane, right?
Yes, sir.
And if it is very slow, then it will go down the plane. So the question is, what is the minimum acceleration the wedge should have in order to keep the block at rest? So what is the minimum acceleration you think the wedge should have?
So in such a way that the friction
So
is
first of all,
actually
yeah, you can write mg sin theta. You know the limiting value of friction is mu s n, correct?
yes, sir.
And this is n. But mu s n is not sufficient. Okay. In the first case, so what you do is you kind of accelerate the wedge to get a pseudo force which can enhance the normal reaction, right? So what you write here? You write mu n plus ma cos theta, mu n plus ma cos theta equals to mg sin theta, right?
Yes, sir.
And what else you write? You will say n equals to ma cos theta plus, sorry, ma sin theta plus mg cos theta, and then you substitute n here and you rearrange to get the a. This is the
Yes.
fundamental way of solving,
Yes, sir.
correct?
Yes, sir.
So you should try the basic method. No? Why you're trying to see? Every time I say, whenever you learn something new, first you attempt with your own method, which you are confident with, and then try to apply the method which you're learning. Because anything new will take some time to digest. So
Yes,
it's a question of pseudo force. Although
yes,
pseudo force is not required, but you guys are okay with pseudo force. That's why I'm saying okay, it's a pseudo force. We can easily solve without pseudo force.
um,
Tell me, guys, you all are clear?
Yes.
So in the previous problem, if I ask you what is the maximum force, what will do? The tendency of the block will be to go up the plane. So mu1 will reverse,
Sign will be changed.
correct?
Yes.
So mu1
Yes,
will
sir.
be, the R will be below the normal. By the same angle alpha, but below the normal. And therefore sign will change. In fact, you will get the answer as the A max can be G tan theta plus alpha. That's it.
Yes.
You can derive this. Can you? Yeah, you can. So that is the whole idea. Can you solve this? Okay, of course, solve by the basic, the way you know.
Yes.
A similar application is on the banking of road. So first, I will not tell you that how to solve, but okay. So let's say you are on a banked road. This is the cross-sectional view of the road. I hope you know this question. And you're moving on at this level. So this is the circle you're moving into. So I mean, this is your plane of rotation, motion actually. And friction you have to assume as static. Let's say you're driving a car or bike. So car, bike will experience the static friction. The tires are rolling actually, it's not steady. Okay. And I'm assuming that tan theta is more than mu, so it means it is difficult for the object to remain at rest. I hope you know this track. Have you seen this track? In the racing car racing, you can see.
Yes.
Yes.
So this is the cross-sectional view, and the circle part is like if you are traveling at a certain height, you will make a circle, right? Eventually, like this. So context is clear. Okay. So the question is, if tan theta is more than mu, what is the V minimum the car must have in order to remain at equilibrium at that height? It means you should not slip down or go up. So what is the V minimum required here? Any guess? Okay, can anyone explain me that why we need to have a velocity in order to prevent the slipping? How velocity will prevent the slipping? Any guess?
so velocity will induce a centripetal acceleration towards the center of the circular path that it's moving, which will then counteract the friction.
Velocity will induce the acceleration.
So because of the velocity.
Okay, think something else. I think this will not make any sense. Something else. This is very challenging problem. Like, if you have seen my lecture, you can go ahead and see again. But I hope you don't remember. Anyone? Who will explain? So imagine you're moving on a straight path and suddenly you encounter a curved track. You know what happens? Your inertia is to go this way, right?
Yes.
But can you go this way? No, because there is an obstacle. And what will happen? You actually kind of hit the surface, right? So imagine if you're not coming
Yeah.
from exactly the tangent, you're coming somewhere here. So you will make an impact here.
Yes.
Now, more the velocity, bigger the impact,
Yes.
and bigger the impact, bigger the impulsive. So normal will create like this. A big normal will create, do it like this. And then let's say you're hitting here, then you deflect and hit here. And because you're moving really fast, so you will create again bigger impact, then you will hit here. And this is how it will go. But imagine if the same thing is happening on a track with a particle of size very small, it will continuously change the direction. It is like a tiny motion like this. You won't see the impact, will you? But because you're turning with the help of the wall, you are doing it because you're making an impact. And this impact is kind of soft collision. You don't realize it. So basically the surface is getting, surface has to change your direction in a way. It is coming in the path of the inertia. I mean, direction of inertia. So it has to change inertia, it has to apply force. And to change faster, if you want to change, if the V is really high, it has to apply bigger force to make this change as quickly as possible. So that is why as V will increase, you will experience greater normal reaction, which you don't realize. That's why on a track, by moving faster and faster, you increase the normal. Do you realize this? Your velocity affect the normal reaction.
Yes.
Okay, so minimum V means what? I just need to increase normal good enough to balance me, isn't it?
Yeah.
And when that is the situation, then see the force acting on the object will be gravity like this. What are the other force? Normal.
Resultant.
And what is the tendency of the object to go down or go up?
Go down.
So the friction will act.
Up.
And because we're looking for the minimum, so I can take again mu s if the limiting is reached. And the resultant of the two will go like this. Now you will ask why it is tilted towards left. If I don't tilt left, But what you know? Then I cannot create the centripetal force, isn't it?
Yes.
So what is my centripetal force? What is the force which will let me turn actually? The centripetal force is how much? If you do not know the R definition, if you know the mu s and n, you will say n sine theta minus mu s n cos theta, right?
Yeah.
This is the net force towards center.
Yeah.
Yes, sir.
Let's say you do not know this R definition. And the net force towards center equals to mv square by r. Correct?
Yes.
And the other concept in circular motion is, in the horizontal circular motion or any circular motion, is the net force perpendicular to the plane of motion must be 0.
Yes.
Which means n cos theta plus mu n s sin theta must be balancing gravity mg. These are only two concepts. One is net force towards center. equals to MAC, which is V square by R or omega square R. Other is if you know the plane of rotation or circle, every force which is perpendicular will not contribute in rotational circular motion. You can just balance it. These are two concepts. Do you remember this concept? And there is no concept in circular motion. That's only two concepts. No matter which question you're solving, there's nothing beyond these two concepts. And then no need to solve for n. You can take n common and divide. So if you divide, you will get a V square by RG equals to sin theta minus mu s cos theta upon cos theta plus mu s. And this is basically V minimum, but okay, you can write it later on. So you got the answer? How much? And we know that you can take cos theta comes, it will become tan theta minus mu s upon. This I could have got in the same way if I write R. What is R? So
R cos theta minus alpha is mg.
R sin theta minus alpha, because it's 90, is mv square by R, and R cos theta minus alpha mg. And you know the answer. If you divide, we'll get the V square by R is equals to tan theta minus alpha. That's it. Same answer, right?
Yes.
And
Yes.
it will drastically reduce the writing part, and it's like, yeah, it's easy. We know this answer, but anyway. So you should know both the methods, the basic, and if you can work with R, you can reduce your effort drastically. You can save your time as well. Is this clear?
Yes.
Yes, sir.
So there is nothing like circular motion. Circular motion chapter is easiest of all chapter. You just need to know the very basic thing, how to write, force equation. That's it. Okay, I'll solve a few more questions of friction. And okay, repose question. Okay, repose questions are very famous. So one question before I go to the next concept. So we have a hemispherical ball of radius r, and surface will have coefficient of friction mu s between this surface and the insect. So this insect starts crawling up the surface. At what angle, at what height it can reach? What is the maximum height it can reach? Find y max. Tell me quickly. Okay, got the answer?
Just a minute.
Friction and circular motion, unless you're not very good with these two chapters, you will never be good with rotational values. So if you're not good, practice enough. Practice from resonance sheet or experiment, finish as many questions as possible. So rather than trying to perfect these two chapters, your rotational will become automatically good actually.
Sir.
Yeah.
Sir, is it mentioned that the ant keeps its velocity constant?
No, there's no velocity. You start crawling actually. There. So you cannot reach beyond certain height. Why?
Because
Angle of repose.
Hmm?
Angle of repose.
Yeah. So as you climb up, your tangent will have bigger slope, right?
yes.
So the moment slope will become equals to angle of repose, you can't go further up. You will slip back. That's the only answer. That's it. And this is a geometrical problem. So of course you can draw like this. And if you say this is theta, this is also theta from geometry. And the radius is r. So the height is how much? 1 minus cos theta plus theta. And cos theta will be how much? 1 upon. That's the answer. I hope this is clear.
Yes, sir.
Yes.
But you didn't get the answer. That's okay. Bye. Okay. So again, we have a wire frame. And it will be given some equation y equals to k square. And again, the same insect problem. So what is the maximum height insect can attain? Given the friction is insect and mu s. Okay, same question. Y equals to k square. Then how high you can climb? The insect can go up to. Tell me quickly.
Sir, mu square by 4k.
Correct. So, so here tan of theta will be equals to 2kx. X is how much? Therefore, y max equals to kx square. This is what you got, right, Asika? Is this your answer?
Yes, sir.
Okay. And again, a very famous question is, so this is what you all have experienced in your day-to-day life. When you pour something, even if you try to pour salt on a table or wherever, you see the heap form is always conical shape, right?
Yeah.
So
Yes.
what determines this conical shape actually? And the answer is same. It is the angle of repose. So the moment slope will exceed the angle of repose angle, this angle goes beyond the repose, the salt particle will start rolling down. So they do have a friction force. Okay. Understood. So if you take it very much identical, and in fact, whatever you pour, it is always conical shape, isn't it? So when you pour something, the H and R will always bear the ratio of mu s for the particle, right? This is like some particle. So tan theta is always mu s, which is H by R. In fact, H and R will have a finite relation. And the rest is no. If I say the volume poured is V, so you can find the base radius also. And in fact, okay, it's very interesting. This could be an experiment to determine the coefficient of friction of the salt particle or sand particle in a dry state. So mu s is how much? Interesting, right?
Yes, sir.
So this could be the problem of JEE Advanced 2030. Will come in future, not now. And one more question. Okay. There are many actually. So we'll come to the two block problem quickly, because that is the essential part of friction. This is what I discussed in theory in a regular lecture. I hope you have not seen. M1, M2, mu1, mu2. Okay. And now I'll give a condition. Case one. So mu1, and they are very close to each other. Mu1 and mu2. So what will be the acceleration of the block? Tell me. So will it have any acceleration? Tell me.
No, sir.
Yes, sir.
So what is the acceleration?
Zero.
Zero. Because both are less than repose, right?
Yes.
Ah, no,
Yeah.
no, I have made a mistake.
Sir, it's the opposite. like-
It's
Opposite.
opposite. Yeah, they will have acceleration. No, first case is more than two. The winner is friction. So A1 equals to A2 equals to
0, no.
nothing will happen. I mean, of course, both are balanced by the respective friction below the surface. Okay, and because if they are balanced by the friction, will they press each other?
No.
So in fact, there is no normal reaction between them. Okay. We'll take the next case. So case 2 is mu1 is the winner, mu2 is the loser. So M1 is who is ahead is not willing to move, but M2 is willing to, in fact, will try to move given the opportunity. So what will happen in this case? M2 will press M1, yes or no?
Yes, sir.
And the pressing force may overcome the limiting friction of M1. Quite possible.
Yes.
Then how you are going to check whether if they'll move or not together? See, they cannot move independently, isn't it? Because M1 is not willing to move. But M2 is trying to move. So there are two possibilities. Either they will not move or
They'll move together.
they'll move together. So how are you going to justify, find the condition under which they will move together? So technically you
The
will first
contact
find the,
normal should be greater than the friction force acting on M1.
pardon?
The normal acting between M1 and M2 should be greater than the friction force acting on M1.
Should be greater than, no, not friction, should be greater than the net value. In the limiting case, what force you need? Like how much normal we need to add to make it limiting for the M1, right?
Yeah.
But you are not going to check in that rigorous way. There is a simple rule for the same. Because the system will move together, and for system to move together, there's only one condition. The net force on the system due to gravity must exceed the net limiting force due to friction. Got the condition?
Yes.
When it comes to system, then we can just check the resultant force, the net force, not the internal force. So that will be taken care by this kind of assumption as well. So what we'll say is to move together, the net gravitational pull, which is this, am I right? Hello.
Yeah.
Should be greater than the net limiting friction. What is that? Tell me, guys.
mu1 M1 G cos theta plus mu2 M2 G cos theta.
Correct? And what a coincidence. You can see there is something really nice, beautiful. Mu1, M1, mu2, M2. the weighted average of tan theta. And this we can call as mu effective for the system, isn't it? There are two block system, right? So what is the effective mu for the system? Mu1, M1, mu2, M2 upon M1 plus M2. This is like finding the average, right?
Yeah.
And who is the winner? Slope. So to move together, the slope must be winner compared to what? The effective mu, not individual mu. Hello, hello, hello.
Yes, sir.
Yes.
And if I just name is mu effective, I can write the therefore A1 equals to A2 equals to A in this case equals to the single block system G sin theta minus mu cos theta, right? If you remember,
Yes.
no need to solve. You can do it mentally by the single block question. If you remember, do you remember? Hello, hello, hello.
Yes.
So now, do you realize that how to solve question when we have two blocks? So I'll give some.
Yes.
2 kg, 3 kg. Okay, what is mu effective here, by the way? Let's find mu effective first, without solving. Mu1 M1 0.4, mu2 M2 0.3 upon 5. How much is that?
0.14.
0.14.
1.4. Huh? 1.6.
Yes.
1.4.
1.4.
Now, I need to create theta which is more than this, but less than. So tan theta. No, this is a tough work for me to create the value. Oh my God. No problem, no problem. I'll do it. Tan 15 degree. No. 10. That's good. So given in the problem is given. See, this J will do. Tan 11 degree equals to 0.194. Very smart. Okay. This is 11 degree. And the value is given 194. Let's keep 19. Yeah, 194. Now what will happen? 194 is more than less than this. More than this, correct? Hello, hello, hello. Am I audible? Hello.
Yes.
Yes, sir.
So now you can see that, okay, they will mention, see, when the values are like this, they'll give you sine, cos, all values of 11. So sine 11. Oh, wow. For a small angle, sine 11 is
Can be
almost equal, what it's 1.190 actually. And cos 11 is very high. Cos 11 is 0.981. Anyway, so can you find the acceleration? Take GS 10. So A will be in how much? Because now this is exactly the condition of our, right? This condition. So on G10 sine is 0.11. Mu effective is 0.14 into cos 11 is 0.9. Let me check into oh, that's small minus 2.1 into 10. So it is roughly coming 0.5 to 5. Okay, so this formula is very interesting. If they move together, you can no need to solve separately, just solve like this. And there is even more interesting. What is the reaction force between them? Any guess? Reaction force. Hmm. Can you find the reaction force? This is, you can just give. So you will also get a very interesting answer for the reaction force, which you can remember or make a note somewhere so that you can always watch it and do it quickly. So what is N12 in this case? If they are moving together, for A1 equals to A2, that is tan theta is more than mu effective. What is the N12 value? Tell me. Hello, hello, hello. The normal between them is how much? So to find the normal, you have to write the ABD of anyone. And you will get the answer, which is no idea. Are you guys calculating? Hello, hello, hello.
Yes.
Yeah, do the calculation, tell me the answer.
So can you show the values?
No, no, not. You answer this in this way. Not for this question. Here, here. I want N12 here. This I gave you example that how you can expect question in J advance and how you can solve in one line. Once you realize the event is taking place.
So mg mu cos theta minus sin theta.
This one. How much you said?
Mg into mu cos theta minus sin theta.
Me cos theta into sin theta like this.
Minus sin theta. Minus.
Minus. Like this.
Yeah.
No, I don't think so. And then where is mg? M is not there. M1, M2 we have. Where is M coming from?
Yeah, m1
No. M1g sin theta minus mu mg cos theta plus N12 equals to M1 to A. A what you got?
I'm getting M1G cos theta into mu1 minus mu effective.
Mu minus mu effective.
Mu1 minus mu. Yes, sir.
Okay. But I think this is the first one. Net
Yes,
force
sir.
equals to mass into acceleration. So if you solve, you get
Yes.
M1 A minus M1. And A is how much? G into
Sin theta minus mu
And
effective.
it mu effective cos theta.
correct. And if I take M1 G common, it is sin theta minus mu cos theta, right?
Yes.
Or mu1 cos theta, correct?
Yeah.
So we can take M1 G common, what are we left with? Sines and cancel, right? It
Yes.
is mu1 minus mu
Mu
effective.
mu effective. Yes.
And it looks like something like mu effective, like, but anyway, that's too much. It's mu1 minus mu effective into M1 G cos theta. But if you rearrange, you will get even better answer. This is not difficult. It's like n equals to mg sin theta into mu, but in the mu, let's substitute the value of mu, which is mu1, which is mu m1 plus mu2 m2. So I generally don't remember, but you can just make a note of it and remember it. So mu and m1 gets cancelled. So what we getting is mu1 m2 mu2 m2 into m1 g cos theta upon, and what will write is like a reduced mass in m1 m2 by into difference of coefficient d minus 1 into d, which is like a reduced mass into difference of coefficient into. This is interesting, isn't it? So the reaction force is like a reduced mass. If you write like a m mu, I will say this as a reduced mass, just to make it easy, into g cos theta, and then we multiply with the difference of coefficient. So eventually, it's easy to remember. If you can remember this, it is easy for you. And it is always the big minus small. Of course, the front should be bigger, and the back should be small. Then we see the answer. And there's one more interesting answer. Okay, so the next is mu1 and mu2 both are less than 10 theta. But mu1 is more than mu2 again. You know what will happen? Any guess? Now both wants to move down the plane, yes or no?
Yes.
Yes,
But
Yes.
who wants to move faster?
that depends, right?
No, who wants to move faster? The dependency is given.
Mu2 wants to move fast.
M2.
M2 wants to move
M2.
faster, right?
Yes.
But M2 is facing M1 in its path.
Yes.
So can it move faster?
No, they both have to move together.
Again, they'll move together. This is again the same answer. Therefore, the relative, the A will be again the same answer. That's very interesting. It doesn't matter what is the context in which they are moving together. If they are moving together, this is the answer. You can save your time enormously, isn't it? No need to analyze. This
Yeah.
question is the most difficult part of JEE Advanced, and that's why I'm trying to explain it there. You can save time by removing this simple answer. And not only this, it is the same answer, mu g cos theta, difference of the mu. Yes. Do you realize this?
Yes.
And this is some case number 3 maybe. And the case number 4, which is really of no use. Both are, and mu1 is less than mu2. What will happen?
Both will move independently.
Will they move together? Will they move together?
No, sir.
No.
No, this is like simple question, right?
So this is
They
like a
both-
two blocks are moving independently. I mean, why we are thinking as two block system? So the answer will be separate. Sine theta minus mu1 cos theta for the first one. And as I said, mu1 is small. So this is bigger answer, right? A1 is more than A2. And therefore, what is the A relative? Tell me. Correct? Hello, hello, hello.
Yes, sir.
Yes.
So because of the A relative, they might start together, but after some time they will have separation. So what is the separation after time T? Right? Hello, hello, hello.
Yes.
Yes.
So they may ask you that question, find the time after which they will have this separation. Yeah, many questions can be asked. But the reverse question is this. This is the reverse question which was asked when I wrote JEE. So I remember this question in my classroom, like when I was writing actual JEE subjective paper and this question came. And I got very happy because I was knowing the answer. 2004 JEE Advance. I clearly remember that question because I was writing it. So theta is given some nice value. How much? I'll come. Anyone having the book in which the 2004 question is there? I think Mugdha is having 2004 paper.
Sir, I need
So
to
you have
bring the book.
from where? How far it is from your home?
Wait.
I'll also check. I think in the resonance sheet you should be there. Just check. You guys are having a resonance sheet of
Yes, yes.
friction. Just check, no? Just check. The resonance sheet.
Sir, it has problem from 2006.
Oh, no. No problem. No problem.
Okay.
See, in JEE Advanced 2014, they have given the similar problem. Even before also they have asked. So JEE is very much into this kind of problem from friction techniques. Okay, Nikhil, don't worry. The question is this. Okay, I remember the answer also, but the angle apart I'm forgetting. So we have two blocks. So let's do this. So I'll solve in general. This is the L. And this is given coefficient of friction mu1. This is given mu2. Mu1 and mu2 both are less than tan theta, but mu1 is less than mu2. So who will move faster? So which object will move faster?
The one at the greater.
M1 will move faster, right?
One.
So the question is after what time M1 will change M2?
Okay, means we can just find out the different accelerations and then apply now.
Exactly. So we have to do the same thing
Kinematic
after what
equation.
time? Yeah, it's just like we find the relative. So the relative separation is the L, and we know that A1 is going to be more than A2 into P square. So the answer is. So kinematics will come with laws of motion, will come with friction, with circular motion, and with everything else in the world. So kinematics is very, very crucial. And I think this answer we have just done. What is this answer? So the bigger value minus the small value into G cos theta, right?
Yes.
Yeah, fine. So let's say 0.2, 0.1, 2 into 1 meter if I put 2 meters. This is 2 meters. So 1 kilometer. And this is is 10. And cos theta if I take as 60. This is fine. L is 1. So if I take L equals to 1, yeah. This way I can create a right equation. So let's say L equals to 1 meter, theta equals to 60. Okay, this is 60, this is fine. G cos theta was there. So
Sir,
cos
question,
60. Pardon? You got a question?
Ah.
Okay.
Separation is √2 meters and theta is 45
Ah.
degrees.
It's the same way. Okay. So I made a new question. And this is 45 degree, right?
Huh.
So you get the similar answer. And what is mu1 mu2?
Mu1 is 0.2, mu2 is 0.3.
Oh, fine. It's the same thing. Like the difference will become 0.1 eventually, right?
Yeah.
So 2 into √2 upon 0.1 will come here, and G is 10, and this is 1 by √2, right? Which is same answer. I remember the answer. 2. Because I got 2 that year. That was the right answer. Anyway. So not a very difficult. They ask easy question only. Next. So in friction again, we struggle with 2-block problem. So we all struggle. I mean, sometimes I do a struggle. So we'll start with the easy one. And we'll try to. So this is the question from IE Rodab. I hope you all have seen this before, but we are going to just do this once again. So the biggest issue that we face when we solve 2-block problem is that how to write the frictional force, right? So F is called the driving force. Can you tell me the driving force will drive which block?
M1, sir.
So if I assume there is no friction anywhere else, then how M1 will move? Right or left?
Sir, right.
Right.
Very good. M1 will move right. Now, once you know the direction of motion, when you assume there is no friction, you get the tendency actually. So when M1 will try to move towards right, how friction will try to act on M1?
Leftwards.
Left.
Left.
So now see how we start the ABD. ABD is not started with M1 or M2. ABD starts with the force, which is the driving force. Now the problem is, sir, what happens if I have two forces, F2 and F1? Then how you are going to draw the ABD? That is very difficult situation that we come across. Then again, the rule is same. Assume there is no friction. What will happen? Assume there is no friction between the object. Ground may have friction, but let's say I'm taking 0. So assume there is no friction. How M1 will try to move? What is the possible acceleration of M1? F1 by M1, and A2 will be. You have to check the A1, A2, not the force, to get the tendency. So I might apply 100 Newton on a 20 kg, and I might apply 50 Newton on 15 kg. Which one will move faster? Or maybe 10. 5. 5 is better. So which one will move faster, M1 or M2?
M1.
Okay, so the whole idea is how to think about it. To think about, you have to find A1, A2 mentally. Now, this is not the solution. You have to just think this way. A similar situation you may face when you are solving question under gravity. And in this case, what is interesting is if you assume there is no friction anywhere, then both will have same acceleration, G and G, right? Correct? If there is no friction,
Yes.
then M1, M2 will go with G only. No, there is no option M1, G, M2, G.
Yes.
So, is there any tendency of relative motion between block M1 and M2 right now? The answer is no. So, will there any friction be between the block? The answer is no. So, they will move together, free fall, G, G. Is this clear? Does it make some sense to you?
Yes.
Yes.
But suddenly, one fine day, I say no. M1 is touching the rough wall. And because of this, even if you assume there is no friction between the block, will they move with same acceleration? Will they move with same acceleration now? If the wall is rough? So you always assume the friction between them to be zero, but we cannot assume the friction of wall to be zero. So now we can see that the tendency of M2 is to move faster than M1 for the obvious reason. The wall will drag and will slow it down, isn't it? Tell me, guys.
Yes.
Yes, sir.
You all realize this part?
Yes.
That the rough wall will not let M1, M2 to free fall. I mean, at least
Yes.
M1 not to free fall. And because of this reason, okay, here the friction in this part will be extreme. I mean, of course, zero. If this is zero, then no friction will develop at all between the block. And the block will just move free fall. So here the A1 equals to A2 equals to G. That's the answer. But the moment you introduce the friction, and why I am emphasizing this problem, because I have seen students who is struggling with this kind of problem. So we have mu1 and we have, of course, mu2 here. Even see, to find the tendency, what we do is we assume the frictional forces between the object to be zero. But I cannot assume this friction to be zero between M1 and the ground, right? I mean the wall. So in this case, even with your assumption, which one can move faster? M2 or M1? Hello, hello, hello. Which one can move faster or should move faster? Hello? Which one? M1 or M2?
Sir, if we're assuming no friction, then M2.
Yeah, correct. So that is how you start with. No? See, you assume no friction to get the tendency first. And therefore, in this case, the ABD of M2 will be M2G down. And how the friction will be? F upward. And therefore, the ABD of M1 will be F downward, M1G downward, and of course, F2 upward. I mean, let's call F1. And then you will solve beyond this point. Okay. So you will check whether F1 max plus M1G is exceeding F2 max or not. You have to check actually. I mean, you can't just write the laws of motion. Yes. You can't. So what will check? Is F2 max more than M1G plus F1 max? Answer, yes. A1 is 0. If F2 max is more than or even equals to this value, it means M1 will be always balanced. So A1 is 0. Then you can go to M2. And then we'll check. What will check? Is M2 more than F1 max? Is M2 okay, is answer. Yes, A2 is also 0. And if both answers are correct, then what is F1? Hello, hello, hello. What is F1? Then F1 is M2G. Hello. Hello, hello,
Yes.
hello.
Yeah.
Because it's simply question of equilibrium. In fact, F2 is M1 plus M2 into G. Because F2 is balancing the entire system,
Yes.
Yeah.
and it is also coming from FBD because F1 is M2G, F2 is M1G plus F1, which is M2G, which is in turn M1 plus M2 into G. Do you realize this what I'm just discussing here?
Yes.
Yes, sir.
Okay, so I'll come back to this problem. In this problem, see, it is like, if you remember the graph of friction, the kinetic can only be seen when you have already crossed the limiting, isn't it?
Yes.
Imagine
Yes.
this as a lake on a mountain. And to see this lake, first you have to climb the mountain. So in any question of friction, which force we have to deal with first? Is static friction or kinetic friction?
Static.
Static.
Only when we are sure that static has failed, we'll go to the kinetic. That's why it's an organic solving problem. Like you have to think organically that is it happening? I mean, is static failing to do its job? And if the answer is yes, then you put broad friction called kinetic into picture and then solve the question. And solving question based on kinetic is easy because you have to write mu k into n. That's it. But we cannot solve question in a similar way when friction is static because there is no formula. You have to check actually. So you will assume the friction, you will solve the FBD, you will get the F answer, and then you check, is my F, which I calculated, is more than limiting or less than limiting? Is this clear what I'm saying? Is this clear what I'm saying?
Yes, sir.
What you're
Yes.
supposed to check. So now if you go back to this problem, let me go to the next problem. And the driving force is acting on M1 in this particular case, which is time dependent, proportional to time. As T will grow, the F will grow. And there is a coefficient of friction mu between the block, but the ground is smooth, I am assuming. And clearly, because there's only one force, it's not a rocket science to understand which one will go which way. So what is the tendency of M1? Definitely to go right?
Yeah.
No, right is not sufficient. Right with respect to the lower surface. Correct? Because it is the surface which will apply friction. So the surface will apply as per what surface will perceive the motion. So the bottom, the top of M2 block, which is the bottom of M1. So from the surface in contact, you will see M1 and you will realize that M1 is trying to go right. Isn't it? And therefore friction will act left. Do you realize what I'm saying? I mean, are you getting confused?
Yes.
Yeah. Is this clear what I'm saying?
Yes,
Yes, sir.
And now we can say something that the same friction from the Newton's third law will act right. And that is how you complete the FBD. Of course, you draw the n dash, M2G, M1G. And what next? How you start with? So to move together, we need certain amount of frictional force, right? And we have no idea whether they will move together, they'll move separately. Who the hell I am to decide? I am no one. So what I do is I make assumption. So always start with the assumption. What assumption? Let assume they are moving together. Because the first friction is static, which will have tendency to move together, right? Static means no relative motion, which means moving together. Okay. So we'll start with the assumption they are moving together. And if they are moving together, then we can find the A directly. So A combined is A by, I can write in one line. You can also write in one line, correct? This is the A with the assumption they are moving together, correct?
Yes.
Yeah.
The next step is to find the F. And to find the F, you have to draw the ability of either M1 or M2. Always choose the easier one. What I will choose? M2 or M1? To find F, what
M1.
I'll do?
M2, sir.
M2, because F is the only cause behind the motion of M2. I can add M2 into A combined, which we got. See, we got the answer. Isn't it?
Yes.
And the other thing which we know that the friction force required, this is called the requirement. And what is the availability? You have a deal. See, you go to a market, you have some money in your pocket, and let's say you want to have some pani puri or golgappa, whatever you say. And the price is, let's say, 100 rupees. Okay. And in your pocket, you have 50 rupees. And there's nothing like a half plate. You can't ask me for half plate. So if you have 100 rupees, 50 rupees, and the demand is 100, will you have a deal with the pani puri wala? Deal or no deal? The answer is no deal. Okay. But if you have 200 rupees, then deal or no deal? So
Deal,
can you
sir.
have pani puri?
Yes.
Okay, if you have 200 rupees, then you can have pani puri. What if you have 150? Can you have now?
Yes.
No.
Why no? The pani puri will charge you only 100. And you
said
have 150.
200 now.
Yes.
No. Pani puri will charge 100 rupees. You have
Okay,
150.
okay.
Then still you can have deal. Okay, what if you have 120 rupees? Now?
Yes.
110 rupees.
Yes.
In fact, even if you have exactly 100, the deal is done.
Yes.
The whole idea is if the required friction to move together is less than equals to the money in your pocket, which is called the limiting friction, your job is done. So the availability is called Fs max. And for Fs max, we do have a formula. By the way, what is N here? Any guess? What is N here?
M1G, sir.
M1.
M1G.
Now, so to move together, what is the condition? Tell me, guys. The demand by the pani puri wala is this much, and the money in your pocket is, isn't it? So the demand should be less than the money in your pocket, correct? Hello. Tell me.
Correct.
Yes.
And therefore, the F is given as KT. So the T is now what this equation says that till the time T, which is less than some random symbol or number, let's call this as T naught. So as long as the time is less than or equal to T naught, they will move together.
Together.
And if they are moving together, that means that this answer will be the answer. Correct?
Yes.
And this is the constant. No, this is the KT by. So it is definitely proportional to time. But this will be true only if is this part clear? No. Now the question is not over. The next part is so the moment T exceed T naught, what will happen? The demand supply mismatch, right? The required friction will be more than limiting friction. Hello.
Yes.
Yes.
So theoretically, the friction required to move together will exceed the friction actually available. And therefore, that will not be true. But no need to get disheartened. It's a very good day for you. Because when that happens, the friction will become which friction? Static or kinetic?
Great.
Kinetic.
And now, because it is kinetic, then you are at ease of solving, right? Because kinetic friction will have the formula mu into n, correct?
Because now friction will be constant, right?
And it is constant. So now we can find the separate accession A1, A2, right?
Yes.
So what is A1? And what is A2? And what do you realize? The top block will have a time dependent accession, but the lower block will have. Hello.
Independent acceleration.
So constant value, right? Why?
Yes.
Because the driving force is constant, isn't it?
Yeah.
And therefore, it's a very famous. You have to plot a graph of A versus T. So they'll move together up to what time? And see, I have drawn a slope. Why? Because if you see the answer, it is proportional to it's the graph equals to y equals to mx, right? What is m here? What is slope here? Do you realize the slope?
Yes.
Tell me. Is this clear?
Yes.
Yes.
So what will be the next graph? After you exceed this time, what will happen? The A2 will be constant, but A1 will be time variable, right?
Yes.
And you can see something. I have made this slope even bigger slope, right? Why? Any realization? Because now the slope is how much?
Okay.
So it's a bigger slope than before, right?
Yes.
because earlier it was K by M1 plus M2, but now it is K by M1. So it's a bigger slope. This is the graph, and this is a very famous question for IIRODA, right? Hello. Understood?
Yes, sir.
Yes.
Yes.
Just a minute. So I have shared one problem. Can you just solve this question? It's easy.
Okay.
Okay, solved, guys. So it is having similar concept as we did before. Okay, for 10-15 degree, you can use the value. I'll just do the value. 10-15 is 0.268. And you can use calculator to get the calculation done as if not, just to save time. But keep the habit of solving even complex calculation because JEE can be really merciless at times.
Sir,
Yeah.
sir, is the like combined acceleration 6√3 minus 14 by 2√2?
6√3 minus
14 by 2√2, sir. No, sir, the entire thing by 2√2.
maybe it's
Yes, sir.
That is negative value. No?
Or,
yeah, that is negative value. So in that question, it's a similar to the two block problem which we have solved, right? So N12 we used to have earlier. Now the N12 is replaced by what? Spring force. So the role of internal force is replaced from the reaction to the spring force. There is nothing difference. So what you are supposed to do is, now you know what you are supposed to do. I can directly use the formula which I derive and equate with Kx, and I'm done. You need to see this question as a different question. Imagine the length of the spring is 0. Can you imagine? Okay. Or very small. And what will happen if the front block will try to move faster and the block which is behind is trying to move slower? So the spring will elongate, but eventually both will move together, isn't it? So here we don't have choice also. We know that they will move together only. And what is the role of the spring force? Is it acting as internal force, isn't it? The only job is internal force. Is there anything else? Hello, hello, hello. Am I audible, guys?
Yes, sir.
anything else in the
Yes.
sense?
Yeah. So in that problem, question number 23, right? P23, right? So if they move together, what is the A must be G into sine theta minus mu effective. Do you remember this answer? So the problem is when it was a regular problem in which you actually were writing the N12, the normal reaction, you were great. But now that normal is replaced by spring force. But it is still internal force for the system, isn't it? And my system is moving together. Am I right? Hello, hello. What happened? Am I not audible?
Yes.
See, you are.
So respond. Yes. So what I'm asking? Hello, hello, hello.
Yes.
Say that the normal force is replaced by spring force in this
Yeah,
case.
so it's a similar problem, right? When two block system is there moving on a plane under the different frictional value, you know the answer, isn't it?
Yes, sir.
And it doesn't matter which internal force I bring into picture. If they are moving together, the A is going to be how much? G sin theta minus mu effective cos theta. I think everything is given. The G is how much? 10. 9.8. Nothing is given.
Sir, 10, sir.
Given. Okay. Sine 15 minus what is mu effective? I think you know how to find the mu effective. Mu1 M1. Have they given the value of mu1 M2? mu1 mu2, right? Tell me, yes or no?
Yes.
Yes, sir.
How much is mu1? I mean, you know the value. You can draw the diagram. My mu1 is the below one, right? Doesn't matter. So what is here mu? Tell me, guys.
0.
What is
Sir,
0.2?
0.1, sir.
1. And this is 0.22, right?
Yes, sir.
And now, so definitely the M1 will try to move faster. So the spring will elongate, isn't it?
It's 0.3.
Oh, sorry, it's 0.3.
0.3.
But anyway, the idea is M1 will move faster. M2 will move slower in general, but
Yes.
because of the spring,
Yeah.
they are moving
Yes.
together. It means the spring is creating the internal force to make them move together. I mean, it's a similar question. What is the answer? Mu. What is M1 given? Tell me.
Both are 3.
Oh, that's so it's like average of the mu1 plus mu2 is 0.2.
Point. Yes.
If m1 m2 are equal, then it is average of mu1 mu2.
Yes, sir.
So it is 0.2. So 0.2 cos 15. I mean, 2-second question. If you know the theory really well, if you understand the concept, or even if you try from solve from basic, you'll get the same answer. And if you don't believe, you can do it. So you will write m1g sine. Okay, masses are same. I like easy. But why? I will write the because they're moving together. So the net force is how much? 2mg cos theta minus mu1 plus mu2 into g into mg sin theta. Sorry.
Sine theta.
Yeah. No. mg cos theta. Oh, what I mean.
I think you wrote.
Yeah.
theta.
Opposite. Yes. So 2m g sin theta minus the sum of coefficient into mg cos theta equals to the total mass, which is again 2m into a. In one line, you can write like this. And the a is how much? You can see the answer. It is g sin theta minus by 2 into cos theta. And this is what I wrote, right? The mu effective. But if I'm not able to solve, then this is not good. Like, no, you must have solved. So what was the first question? The first part was what? Tell me.
First part was to find the acceleration. Second part was to find the acceleration.
Find the value. Oh my God, the value of acceleration. This is okay. This is fine. Okay, I'll leave this alone. And the next part is extension. Come on, you know the extension. No, okay, I'll add directly. Reduce mass, difference of mu, which is into g cos theta, right? And the reduced mass is m by 2. Difference is 0.2. G is 10 cos 15 by k. Mass is given, yes or no? I don't know. Mass is given. Mass is not given. 3 kg.
3 kg.
3 by 2 k is 200. Cos 15, who will tell me cos 15? It is 0.9798. What? 0.9798, yeah? Something like this. Anyway, cos 15. 0.965, 9696, 0.96966. 966, yeah. So the answer is 3 into looks like 1.45 centimeter, right? Question number, how much? 20, 23, no? 23. Let me tell you the answer first. 23. 1, 2, 3. So answer is this is the answer. And the acceleration is 0.656.
Yes.
See, we can solve the question with direct derivation, the answer which we have got, right? We can save time. But no need to save time. You can solve from basic if you're not confident. Okay, do this next problem. Okay, if this is not clear, let me know. Do you want me to solve other way around, like by writing the equation?
So to find the extension, we'll basically equate the acceleration of both the blocks, right?
No, you just simply write the ABD of any one block and write the laws of motion. Because if you write one of them, then spring force will come into picture. And you know the A, na? So you can write the equation, this entire thing. So M1 G sin theta minus mu1 M1 G cos theta minus kx equals to M1 A. A is given to you, you will solve and substitute and get the answer. But
Yes.
what I'm saying is you can do it really fast. If you remember certain things, this is a very standard way of solving question. And you can solve really fast. I mean, if you can really crack this. Solve the next question, which okay. It's here. Can you solve this question? You all understood the question number 23? Yes or no?
Yes.
See,
Yes.
if you want to solve by the basic, you are most welcome. But you can imagine how much time it will consume. I'm trying to create something shortcut for those typical problem which I'm expecting in JEE Advanced. So these are standard problems. You have to write the answer and keep somewhere like keep on revising. Okay, this question I can solve directly like this. So for two block problem, we always have standardization of solving. Always. Always. Yes. So imagine if someone is asking you this question. I'll give you this question. You know what it is? Okay, just a moment, we'll go back to the same problem. I'll just give you a very standard answer. Why we got the answer the way we got the answer. So I'll solve this question in small, and this is like true for any two block system. I'll show you the advanced method, slightly advanced. Try to digest. Okay. So Newton's laws of motion, F equals to ma. Newton's laws of motion for reduced mass system, for two block system, F mu equals to mu A relate. Oh, I like this. It is called reduced mass into A relative. Oh, that's it. Over. What does it mean? Okay, if you ignore the internal force, what will be the acceleration of M1? So it will be F1 by M1 towards left.
Yes.
What will be the acceleration of M2? F2 by M2 into right.
Towards right.
Correct.
Yes.
So what is the relative acceleration?
Plus F2 by.
And what is the reduced mass? And this is due to the internal force. We write this. This will become actually internal force. So in this case, it is spring force Kx. That's it. One line answer. Over. Similarly, if I ignore the spring force, what is the acceleration of each block? So you know the A relative here. Both will move in the same direction. So this is A relative. Do you realize this? Maybe. Do you realize this is A relative actually? And this is reduced mass.
Yes.
And this is internal force. One line answer. This is the beauty of any two block system. You can always write this equation. This is very advanced. I mean, of course, this is what you study in MSc. But if you can just keep this in mind, you can save a lot of time in the competition. This is one line answer, right? Internal force is how much always? Mu into A relative. For two block system, you can always apply. So what is the internal force here? So I think A relative is here, right? It's easy. G into sin theta minus mu1 cos theta, right? And I think I don't know which one is bigger, but anyway, if A1 is more, so A1 plus A2 is the A relative, correct? And how much is that? If you subtract, you can see the answer. Am I right? Isn't it?
Yes. Yes.
Yes,
And that is why I can directly write the internal force by this relation. In fact, this is a question from center mass sector. A challenging problem. Find the elongation. We know the answer. It is no longer challenging. One line answer. Can you open the SURMA and see the question? I'll tell you which question. So many questions can you solve in one line if you go deeper into mechanics. So in center mass sector, question number I'll tell you 52. You can read the question, right? And you will realize it's very
So
easy.
can you send a photo of the question?
Yes. Right away. So if you know the laws of motion really well, you can do it in your own way, writing too many equations. This is what we solve in the CM frame. But even without using CM frame, we have a ready-made formula. The F mu is mu A relative, where mu is the reduced mass. This is very, very important. Is this clear, guys? Do you learn something here?
Yes.
Of course, this is not, part of the regular JEE preparation, but I'm just giving you because you're coming here, so you should get something extra. Any challenging problem can be solved with ease in one line or a half line, 6 seconds. So this formula is again, always I say to remember, okay. No need to go back to your rudimentary method to solve. If you have practiced enough, of course, I mean, I believe that you are expert in writing the laws of motion.
Yes.
Then this is good. Okay, read the question. Understood the question?
yes,
Okay. And if I change the direction of force in the same direction, then A relative will be difference of the acceleration, right? It will be difference, correct? So here
So can I
in the no, if the F1, F2 are in the same direction, then it will be difference, right?
yes, sir. Then it will be different.
And even if I swap the force, you can still write the answer. F2 by M1 plus F1 by M2, right?
Yes.
So whatever I do, you can write the answer because you're not going to resolve from the scratch. Isn't it some benefit? Okay, that's benefit. Okay, it depends like how you perceive this knowledge. Can you guys solve this question? I gave some time back. will be solving a lot of questions when I'll finish the work energy power. I'll just take you through the working power. Then we'll come back to the circle motion in more rigorous question we'll solve, and we'll also solve some question of rotational dynamics, especially the laws of motion part. So what I'm trying to do is I'm trying to take the laws of motion of dynamics also here itself. Okay. What you are supposed to remember, okay, I will not be teaching you the moment of inertia. So you all have to watch the lecture or see the notes or do in your whatever in your capacity and try to understand the moment of inertia. The rest part, okay, we'll be solving here some challenging problem. Through that question, you will come to know how to attempt question of rotational dynamics with ease. Most question of rotational dynamics can be solved mentally. So, but I think right now you are mature enough to learn that method. I have taught that time also, but okay, you don't realize as a first time or the no one realizes. That's okay. Okay, Jess, you got the answer for this question? Anyway, let's say if you do not know this method, then how you would have solved? Tell me, anyone who can share how you would have solved.
Sir, without that COM frame.
No, whatever, without my method, like the last method which I taught. Without that method, how you would have solved?
Sir, FBD and solving.
Yes.
So can you solve without this method? Okay, solve. And the answer what we have got is called the equilibrium position. Like, this is not the maximum, this is the equilibrium expansion. Elongation at equilibrium. The maximum is always double of this, right? If you remember
Sir,
the
which
maximum,
question are you talking about?
52. The SC Verma question which I have shared.
Oh, okay, sir. I thought
Yeah.
you were talking about the question which
Yes.
you're displaying at the moment.
Okay, anyway, you can do that later on. Do this problem first because we are doing friction. We'll go back to that question later on. Not an issue.
Sir, the HC Verma question or the
No, you do right now this question. Solve this one.
okay, sir.
Okay.
That will do later on. This is also inspired from SC Verma. I mean, this question is, of course, the last question of SC Verma, that question number 31. We might have seen, I think. It's given, sorry, length of cart is given. Yeah, this is given, right? 50 centimeter. Yes. Time is given. Mass is given. I think the rest you can do. G, you can take 10. So if your basics are in friction is not very clear, then I'll suggest you can go watch and watch the video, because friction videos are very less, hardly 3-4 videos. You can watch the last 3 videos. I mean, first all videos, if you want to get all understanding of basic also. Your time is an issue for me. I cannot go on digging deeper into the basics, which we have done already. I'm trying to just bring the concept on the surface through numericals.
Sir, I'm getting 41/80.
Just a minute. Under root 14
Oh,
by.
one second. I've taken the length wrong.
It is centimeter, so you have to convert it into meter.
1 second.
Just you got the answer. No, these are easy questions. These are not difficult. Find the accession of each, then find the A relative, then write L equals to half A relative T square. Right? We have done this. So how the cart will move, right or left?
Left,
And how the object will move?
down.
Down. How? Brick means the brick in the cart. The blue one, the blue.
It will be same as the cart, right? Left.
Yeah. With same accession.
Yes.
Relative to the cart, it will move
So
right.
not as the cards. I mean, like there will be relative
Yeah.
acceleration between the card and the brick.
Correct. It cannot be same, na? If it is same, then it will never fall off. Huh?
In ground frame, it will move to the left, but relative to the cart, it will move to the right.
Yeah, of course. So it means they have different accession, right? On the left. So cart is having more accession than the brick, right? Isn't it?
So is it 0.4?
Yeah, I think that's the right answer. Where is this? Let me check. This is question number. We don't know. 32. So your answer is absolutely correct. It's 30.4.
Okay, sir.
So this may come in the integer type also, right? Or numerical answer type, NAT type problem. Okay. I think 10, 15 is not required here, right? It was for the other problem, right?
Yes, sir.
Yes, sir.
Simply write the laws of motion. Don't try to, do anything extra. Just write the laws of motion for each system which are moving together. So like the hanging brick and the cart will move together. So you can take that as system, and the friction between the brick and the cart will be external force for the cart, right? And because they are not moving together, the brick and the cart, so we cannot take as one system. So we have to take as separate system. So these are so many takeaways. I mean, if you read the question, you should understand that what we can assume together, what we cannot assume together. Done? Okay, do it. Take your time. So for this chapter, I will suggest, okay, solve resonance sheet exercise 2 completely. Done? I think we can do one JEE problem just to get some confidence that, okay, you can solve JEE with ease. And the question which you are solving are not just JEE levels, slightly more than JEE as well. So this was JEE 2014 question. Okay, if you are done with this question, just let me know.
Done.
What done? 14 this question.
This question.
Okay, so what was the accession of the cart?
See, we
Send-
don't need acceleration, right? See, what we can do over here is wait, I'll send you.
You send me the solution. I'll see.
check the photo.
Okay, just a minute. So A cart equals to 50 minus 20 mu. What is the mass?
Mass is 2 now of the brick.
Brick is 2. So 20
So,
mu. And what is 50?
50 is that force which you are because of the
Okay,
what we say
okay,
brick
gravity.
outside.
Upon
Gravity.
8. Yeah, that's correct. That's correct. That's correct. So this is
So,
A.
and we can also write of brick as 30 minus 20, right?
Brick as. So the brick acceleration will be mu g only, no mu g.
Huh?
Huh?
Yes, mu g.
So what is the relative acceleration?
50 minus 100 mu by 8.
50 minus 100 mu by 8. Yeah, correct.
And that
So-
we can put in the equation and then everything gets cancelled out. We get 1
Correct.
equal to 5 minus 10 mu. 4 by 10.
Correct. Correct. That's the right answer.
Actually, one thing I was missing over here was length of the card, but then I saw you written down.
This is correct.
So that's why we don't need to use that, right? What we say,
What?
we don't need to find out individual acceleration. Like,
No, you did the same thing. You have to find out the individual acceleration.
okay, I thought you were asking for numerical value.
No. You did the same thing, no? You found both acceleration and then you subtracted.
Yes.
So how can you find the answer without finding the individual acceleration? So it is like, okay, you have to find both the acceleration. Either you find this way or you can find by pseudo force method, right? But that is not required. Okay. I hope this is done. This question is done for everyone. Parv and Darsh, you guys are not responding. Solved, yes or no? No. So what is the net pull force? Okay, so you solved? Parv. Darsh?
Sir, I'm getting one mistake. I'm not sure why I'm getting it that.
So we have to try that 6th question, which is
I have shared something. Yes, 6 one. The JEE advance. So tell me what you're doing. What you're doing, you can explain, then I can help.
Sir, A relative first I got from kinematic equations. It's 5/4.
No, what is the A of cart?
The bottom surface frictionless, no? So it's driving
Yeah.
for 50 Newton minus 20 mu upon mass of cart, which is 3. So mass of cart is
Cart and this block will move together, na? So this is 10T actually. Understood?
so we're writing the equation only for the cart here, no?
So only for cart will be T minus, na? Then it will come T minus 20 mu.
Okay.
T minus 20 mu equals to 3 into A. And then we'll say 50 minus T equals to 5 into A.
Yes.
And then you add.
Yes.
A of the brick will be, or the block is mu
That's
G.
20 mu by 2.
It is just 10 U, no? 10 U.
Yes, sir.
Yeah, now I got it.
And then A relative, of course, the cart must be more than brick, then only it will fall back. So 50 minus 20 mu by 8 minus 10 mu. How much is that?
100 mu by.
And this you can find from here, no? So L equals to half A relative into T is correct. L is 0.4. 1/2 A relative, this is 0.8, right? So this is 0.8 and this will come 1 by 0.8, right? Like 5 by 4. Huh? This is 5 by 4.
Sir,
This is
got that.
10. So 40 equals to 100 mil, right? So it's a very potential good integer type problem, isn't it? Okay, anyway, I have shared the last question for the day, which is the JEE Advanced 2014, which is again based on the same idea which we have discussed. You have to read the question and solve it. This is from resonance sheet. You can open the sheet directly and don't see this. And go to the exercise 3, the JEE. You all have that booklet? Hello, hello. The booklet is shared in the group itself, so you can go and watch. Okay, guys. So what I'll do is, you want to solve more problem today, or enough for the day? I think you're tired because of your school examination also.
Yes, sir.
Okay, so I'll stop it here only. Your homework will be resonance sheet exercise 2 completely, and make sure
Friction,
that
right?
friction, yeah.
Hmm.
And also read the theory of circular motion. You all have notes, I hope so. So
Yes, sir.
be prepared with friction and circular motion. Next lecture, I'm going to take the circular motion for horizontal and then work range power and vertical. So you can actually read up to WEP.
Okay.
Okay.
And after that, we'll jump to the center mass and rotation. Okay. And after that, we are going to do the optics. Only problems.
Okay.
Next lecture will be up to WEP. We'll try to touch up to WEP.
Yes, sir.
Okay. So all right, practice. I mean, there is no other way around to improve your learning. Practice as much as possible. It is not going to be easy. The fundamentals are the challenging one. Rest of the physics is easy, as you know.